And welcome to another episode of In Stereo with Mike and Rick. I'm Mike Bovaird,
And I'm Rick Miller.
and we're talking all things audio. Today's special guest is Garth Powell from Audioquest. Garth is the Senior Director of Engineering for Audioquest, and he's been with the company for a number of years and has really come up with some incredible new products and new lines for Audioquest. Garth, welcome.
Thank you. Mike, Rick, thank you so very much.
No problem.
It's great to have you.
We know how busy you are. We know how many projects you've got on the go, and we certainly welcome and appreciate the time that you've given to us today. And there's so many questions we wanna ask you. But one of the things I wanted to start with was a little bit about your background prior to Audioquest.
Started in the industry around age 15. I've always had, what these days is called a blended career, but there was essentially, before there was any career, it was just blended studies. Everything always had to do with sound. It always had to do with music. Got very, very, passionate about learning music and learning an instrument at around age 10 or 11.
Mm-hmm.
Started private lessons at age 11 and have never really stopped. I've been playing professionally. I went to music school, been playing professionally now for well over 30 years. And then even in my teen years, I was playing in, essentially second and third tier symphonies. I'm classically trained, and later, moved on to jazz and world music. But the thing is that that was always a passion. However, I was also warned by all of my private teachers, and they warned my parents too. Okay, well, Mr. and Mrs. Powell, he's very, very talented. He's going to do well.
Mm-hmm.
He could definitely have a career in this. It's worth, keeping going. He's completely, essentially so dedicated to this. There's nothing you're going to be able to do to get him to stop anyways. He's obsessed. And, this is what you see with basically anyone that's good. Plus, I'm diagnosed OCD, so you add that, and it's sort of like it's a liability socially, but it means you get really good at things that you're passionate about.
Right.
The bad part is that I tended, even though I have fairly Catholic taste in terms of what I'll listen to, when I'm good at playing, when I'm the most talented at playing as a specialist, I was warned by all my teachers, oh my God, you're going to starve.
Yes.
So you better have a backup plan, which doesn't mean the old thing of like make up your mind. No, you can do both. You just, you'll have limitations in terms of how much, spare time you've got, but you could do both. But you're just going to have to figure that out. You're too good. Please don't stop. But, you're going to starve to death. So fortunately, within a couple of years, I also got very curious about electronics. And, I was told by my parents that they got me my first stereo at age 2.
Wow.
Because I don't have any memory of this, but it was essentially they're trying to preserve their record collection, because I would get into their stuff and just destroy everything.
Well, Garth, the same thing happened with me. I actually, in the very olden days, the long time ago, Rick knows this story.
It's a good story.
It is a good story. I actually managed to win Canada's Senior Musician of the Year. I went to the locals, the regionals, the provincials, and the nationals, and won Canada's Senior Musician of the Year in my senior year of high school. And of course, thank you. And I sat down with my music teachers, and I said, well, this is great. I'm going to go on. This is going to be a career. And I'll never forget, Mr. Gillespie looked at me and said, do you like to eat? I said, well, look at me. Of course I like to eat. And he said, don't get into music. And that was pretty much the end of it. I mean, I did a little bit, and I've tinkered ever since, but like you, that was the advice I was given. So I can relate to your story, you know.
Yeah. And this was also, if I think about it, I grew up in Central California. So, and this was at a time before, obviously way before the internet. And it was still a time where if you were in a third tier city, you just didn't have access to a lot of things that people in larger metropolitan areas did.
Same here.
You weren't aware of a lot of, like things and so forth. And what I can realize now is these oftentimes were sometimes very, very talented musicians, but they had families, they had other financial problems, they had other personal setbacks and so forth. And they were already, let's say, a little defeated.
Yes.
So it makes sense that was their attitude. Fortunately for me, nothing and nobody was going to stop me. So, I was singular in vision, and it was like, I'm counting the days till I get out of here.
Right.
And I get to a larger city. So, there was that. But fortunately, also, I was very interested in electronics. And again, I mean, apparently their stories about when they got me my first, stereo, I was apparently completely disassembling the thing and putting it back together before I have memory. So
wow.
I guess that was kind of slated to. And then I grew up in an area with really talented broadcast engineers. And they were all, and I was kind of like the precocious sort of like so-called genius kid that is a social pariah for anybody my own age, but for people 20, 30, 40 years older than me that are willing to put up with the fact that you're a little, like socially awkward, it's fine. Plus, actually, in the case of a lot of them, they were fine with that because these were people that, learned their skills through hard Scrabble. They learned them in the military. Some of them went to engineering school. It went the range, but what they all kind of had in common was incredibly intensely skilled, some of them genius level, but really socially awkward, really cantankerous. Wives oftentimes had left them years ago, so they had time for a precocious kid who was willing to ply them with coffee and sandwiches. And at age 15, it was just sort of like, oh, well, what are we going to do tonight and everything like that, because it'd be the weekend or it'd be summer break or something like that. I said, like, we're going to build a preamp. How do I do that? Well, here's the schematic. I drew it up.
Right.
How do I read that? Well, I guess you're going to have to learn, aren't you?
Yeah.
Parts are over there, scopes here, signal generators over here, go.
Right. And, you must have been reading Popular Mechanics back in the day or something, as well.
Yeah. And so, my God, I mean, like the first few times you just, like you're lucky if the thing doesn't blow up in your face or you don't get electrocuted. But eventually it's like anything else, you get good. If you listen, if you learn, and you just you're intellectually curious, you've got some good people to guide you. And whether it's electronics or whether it's music, I just consider myself a lifetime student. I'm always curious.
Always learning.
I have, in the electronic side, I have all kinds of people that I know in the industry, because our industry is small. And, the thing is that, and people always kind of like think, particularly from the, online media and magazines and so forth. Oh, and just, from a practical standpoint, I mean, obviously you're marketing your wares. And so, there's this competition here and there's competition here and everything like that. There's nothing that makes me happier than learning something, like from a so-called competitor, or purchasing their product or borrowing their project, popping the top, reverse engineering what they've done and everything like that. Not to copy, not to badmouth or anything like that.
Just see what you can learn. Yeah.
Yes. What I can get inspired by.
Right.
And for me, the most interesting part is not that they did this. You still need skill to be able to do that. But what's far more interesting for me is to try to figure out, why did they do that? Because if you can start to piece that analysis together, that can start getting your mind racing towards, what about these other things that I know? What about if that was true, if X was true and Y was true, what about Z? Like what if we went here and so forth? And it's just constant, like defining what the problems are, finding, like other aspects of the problems, new relationships to problems that you hadn't thought of before, and how to deal with them. And it continues to this day. It never really ends. It's when you're dealing with marketing, it has to be a situation where you need a tight story and you need a good story.
Mm-hmm.
And I'm very sympathetic to that. When engineers get together, we talk about everything that's wrong and we downplay everything because that's the culture.
Yeah.
Like if you're hyping things too much, you're kind of drummed out. It's not what another engineer that's really knowledgeable wants to hear, because we kind of know the truth about all this. It's sort of like there's a level to which, like no matter what we do, it's still kind of crude. We know where all the bones are buried. But if you're marketing something, it needs to be some variant of you have been, you have the honor to, partake in this special fill in the blank that represents the finest, most forward-looking technology mankind has ever known. Congratulations.
Absolutely. And
there's nothing wrong with that, because if I'm putting down serious dollars for I'm a road cyclist, for my new bike or something like that, I'll geek out like anybody else. Or I'm professional jazz drummer, so a new handcrafted cymbal, drum, whatever it might be, or something like that. I'm a sucker for all of that too. But there's also another level where when it comes to the making of it, and the designing of it and so forth, it's just it's humbling.
Garth, what year did
you learn something all the time?
You certainly do. Garth, what year did you join Audioquest?
That would have been 10 and a half years ago. I think it was 2012.
2012. And
late 2012.
And what was the first product that you solely designed for Audioquest? Was it the, and correct me, I want to get clarification. Is it Niagara or Niagara?
Niagara.
Okay.
Niagara and after Niagara Falls.
And after Niagara Falls. Was it the 7000?
And that's because of Tesla.
Okay. Was the 7000 the first product?
Yes.
Okay. And tell us the whole concept around designing the 7000.
Okay. Well, actually, it's a bit of a backstory. So prior to my tenure here at Audioquest, I was 16 years at Furman Sound. And I know that that Rick, Miller also, has a deep background, in a little bit of, professional broadcast and so forth. And so it's a similar, situation in that not only are those a lot of the people that trained me, but also, and I was around that at an early age, but also, Furman, we sold to a few, audiophile or high-end dealers, certainly custom install. But, when I started there wasn't even custom install division. It was purely broadcast, professional audio, backline support for professional musicians. That was it. And, it wasn't necessarily my specialty, but, out of engineering, and music school and things like that, I, just needed a job. I went for big companies, Hewlett Packard, AT&T, and so forth, for a time, just kind of like spinning my wheels so I could find something that appealed to me more and so forth, and they would have like massive layoffs, and I'd be one of like 2,000 technical people looking for work. At the time that I started with Furman, there was just nothing else, like available. And I kind of like dumbed down resume to get in, told them, hey, this shipping clerk, a job, I've got a keen interest in this and everything like that. This is something I've always wanted to do.
Just to get in the door, yeah.
And, like I strategically it was a little place, and strategically in the lunchroom, I would, like where I knew all the engineers were going to be and everything like that, I'd pour over the table while I'm sitting there, like I'm eating my sandwich, like all my schematics for a condenser microphone I was working on and so forth. And
very subtle.
Finally, it worked. The head of engineering takes a look at all this and just like, who are you?
I'm the mail clerk guy.
Come to my office tomorrow.
Right.
Yeah. So within about 4 years, I was like lead designer.
Wow.
Like there.
Wow.
And that's great.
But anyhow, and that was an interesting situation too, because prior to that, everything had kind of worked out, but they found out early on in talking to me that I was an audiophile, which I never should have admitted, because in that world at that time, that made you a social pariah, because audiophiles were the people that believed in nonsense. We believed cables make a difference. We believed that that vinyl had some kind of
magic.
Some magic to it that made you want to, that actually make you want to listen to that crap.
Right.
And we were putting, back in the in the peak of the CD age, we were putting, green, penny.
The green, the green marker.
We had putting special expensive feet underneath, products and things like that. We just believed in absolute nonsense. It was all easily disproven. These engineers were all kind of crusty and all had a messianic complex. Right. They were all to save ourselves, save everybody they could, within ear, distance from themselves,
right.
For getting fooled by the pseudoscience. And I was one of these evil people. Well, the thing is, and I would always want to ask them, okay, well, let's see. So all this is subjective, all of this is false and phony, because we don't have peer review, testing, and it hasn't been double blind, and I need an AVX switch box and so forth. And yet I noticed, curiously enough, 3 of you got in line, and froze your behinds off, at 1 a.m. to make sure that you were there first for the new iPhone. And I want to ask you, did it get peer reviewed? Are you sure that processor has been, where's the double blind study? Right. Are you sure you're not getting ripped off by horrible marketing? Right. Because, I want to help you save your hard-earned dollars. Yeah, it seemed to be pretty situational. But anyhow, they gave me one of their most expensive power conditioners, and they were really excited by this because a number of recording studios had been using it and had reported as much as 16 dB noise reduction with everything wide open on the mixing consoles and so forth, which was absolutely true. I've seen the results, and it was, really, really loved by a number of broadcast facilities and so forth as well. And they said, like, oh, you've got one of those fancy stereos at home. Bring this thing home. You'll be amazed. Oh, fantastic. Because at the time, this was thousands of dollars, and there was no way I could afford this, what I was making. So, most of my stuff was, home built anyways. A lot of valves. So anyhow, bring the thing home. And at that time, I'm still, I've got digital, but I'm mostly running vinyl. So, still have a huge collection. So, hook the whole thing up, get my Magic Center seat, dim the lights, put, my favorite cut on and everything like that, and sat down and ready to, be transformed. It was terrible. I watched my soundstage collapse. 1K was blacker, but the high end was at 1 octave bright, other end just dull as could be. Bass just falling apart, current compression, just plain not good. And this was, early enough in that industry. This is the early 90s.
Mm-hmm.
Well, at that time, I'm thinking, oh my God, I've broken this.
Hmm.
You know,
Yeah.
this is their engineering sample. I'm going to get killed.
Right.
So I take the thing out. I pop the top. I'm going through all the circuits. I'm going against the schematic. Everything seems to be okay. I can't figure this out. You know what? Maybe it just needs to warm up. So, put it back in the system, went out, got dinner, come back, listen to a couple of other tracks, same thing.
Hmm.
And then I'm thinking, oh my God, I can't talk about this because I haven't been there long enough at this point to even have medical coverage. Now, you originally from Canada, you
Yes.
didn't have this problem.
No.
In America, it's just like you get to pull yourself up for your bootstraps if
Right.
you want to like not get sick. So
Right.
anyhow, like that becomes a big issue.
Uh-huh.
And so it was one of those things where like, God, I got to keep my mouth shut. Well, how am I going to do this? I know they're going to ask because they're all so proud about this, understandably so. Okay, so I figured it out. Well, the production people come in at 7 a.m, but they don't roll until 10. So I'll get there early. I'll put the thing away back where it was. And, we just won't talk about it. And that should work out. And it did for about 2 months until one of them remembered. And then they all got around me like, some cult film.
Uh-huh.
And all of a sudden, just like, tell us, we need to know and everything like that. Well, some things are for some people and some things for other. I'm just trying to dance around it and everything like that. They weren't having any of it. I could barely get started. Talking out of both sides of my mouth before they were just sort of like, oh, it's the audiophile, and it's just like, oh God. But and I'm never going to hear the end of this. I have no credibility. So there was only going to be one way out of that, and that was effectively I spent on my own dime and on my own time every weekend and every evening. I didn't have a concert or a gig or a rehearsal or something like that. Tearing that thing apart, like put it back together again, measuring it, studying it, trying new things out. And basically I spent the next 2 years figuring out why that unit failed.
Mm-hmm.
That became the genesis of everything I designed for them afterwards.
Mm-hmm.
And I proved to every single one of them my point.
That's very good.
About that same period, this gets old, so a lot of background to get to Audioquest. So about the same period, power was starting to become a thing for a lot of audio companies, in particular cable manufacturers. This was largely due to Monster, no longer around, but big deal at one time.
Yeah.
And, basically the sales team was telling, the founder of Audioquest, Bill Lowe, you got to have power. You got to have power. We got to have power. These guys have power. We got to have it too. Build it and they will come.
Mm-hmm.
So it was a situation where he kind of felt like, I'm not going to just, they're all telling me to just rebadge something and put my cable in it. No, I'm not going to do that. I have too much integrity for that. If we're going to do this, I don't have the expertise for this. We got to hire somebody that does, or we got to find something that's real. So at the time, he asked, his ears and kind of second in command, Joe Harley, he's now Universal Music tone poet, famous jazz producer, Grammy nominees. But anyway, he asked him, buy every power conditioner known to man. I don't care if it's audiophile. I don't care if it's pro. I don't care if it's the IT industry. I don't care if they work out of a garage. I don't care if it's a massive corporation. Buy the best sample you can find of everything. Test every one of them. Let's learn about this. At that time, I don't know of any magazine that had done this.
No, that's great.
And basically the upshot was the top of the line that I designed for Furman at the time, the Furman IT reference, it won. So they immediately decided that they wanted to, do some kind of an OEM between the two companies. I was brought to, Audioquest to meet. They tried to negotiate a deal, it kind of fell through for various reasons. But the upshot there was within a month, or maybe actually a couple of weeks of the whole thing falling apart, Joe Harley called me up and said, you want a job? No, I'm a musician. I'm loyal to the people that I'm at. I can't do it. Thank you very much. But it's just one of those things where, I'm very ensconced in the music scene here and everything like that. It won't work. And then we got bought 2 or 3 times in a row.
Mm-hmm.
And when it became really clear at the end of about 16 years, within 2 to 5 years, none of us are going to have a job.
Yeah.
I
Then it
was
was
the
time
first
to
one.
make a move. Yeah.
Time
Yeah.
to make a move.
Yeah.
I had plenty of, this is close enough to Los Angeles. I have plenty of musician friends down there. I
Right.
got to do this. And it was great because all of a sudden I was back to, like where I started, like off as a, like fledgling audiophile. I was working in a, like a high-end 2-channel shop as a technician, like at 17.
Right.
And, and I had, like basically resources and things like that and sound equipment to listen to like I'd never had before.
Wow.
So that was a lot of fun. So yeah, the idea was that, as like particularly for a cable company, but really just as an audiophile company, Audioquest came to power late. There were a lot of people that already were very well regarded, very well respected, and very ensconced. So the idea was, the sales team would have liked, like a basic strip at around $200 or $300, which I can do blindfolded all day long. But I was just like, no, like start at the top because like if we don't cement a reputation and you try to go the other direction, we'll never be taken seriously ever. Like we need to start at the top, and it better absolutely blow people's minds.
And it did.
No.
And it did. It kind of caught the
Yeah.
market by storm when it came out. And one of the things that I wanted to ask you is, not long after the 7,000, you came out with the 5,000. And what is the fundamental difference between the two?
A 5,000 is essentially a 7,000 minus one important part, and that is two symmetrically powered isolation transformer that actually there's a patent that I was awarded for this that are dielectrically biased, which they the best isolation transformer in the world sometimes will have 1 or 2 Faraday shields. This has 4. And what the reason for that is because, like the sine waves of, the highest frequencies, particularly today with Bluetooth and cellular, they're just so incredibly small that there's almost no part, including an isolation transfer, you can make where they just won't capacitively couple from your primary or your input to your output, your secondaries. So, like the Faraday shield is part of how that's done. And that worked in yesteryear almost perfectly. But then the problem is that even then, what's called the parasitics of these noise inputs are just so incredibly small at this point and so pervasive. There's almost nothing that's good enough. So you just have to keep throwing more technology and more technology and more technology at these things. So that's part of what I did with that design. But that's essentially the whole difference. And it's double the weight, double the expense, and it's only for the source outlets. The power amplifiers don't go through those transformers. The difference between a 5,000 and a 7,000 Niagara, where the power amplifiers are concerned, 0. They're exactly the same circuit. And that's a unique circuit, by the way, because if an isolation transformer, and I've heard some people kind of fudge physics on this, where they'll kind of talk about, oh, well, we've got an isolation transformer and everything goes through it, but it's going to be okay because it stores energy. Well, magnetic energy, yes, but actually, no, it's raising impedance. By definition, it has to. It could be the size of the room, the office that I'm in right now. It's still going to raise impedance. Therefore, a power amplifier doesn't want to know. But your source components, on the other hand, where I've also heard like, oh, every, it's audiophile, it's all high current. No, it's a class A, signal level circuit. It's constant current. You can see that on the specification page at the end of the manual. Like whatever the draw is when you turn it on, unless it has a soft start, is the same current draw basically. At full output. And for those, it might draw 1/4 of an amp, it might draw 2 amps, but whatever it's doing, it's constant. So for something like that, current compression is an issue. Current compression is an issue for power amplifier, though, because those are never going to be, a constant draw. Even a class A amplifier for transients kind of isn't. And this is largely due to the fact that loudspeakers, as great as they are today, are relatively inefficient.
Mm-hmm.
So it's a situation where you're always going to be pushing the power supply of, that power amplifier, which to be good and have relatively, like what's called low ripple,
Mm-hmm.
no modulation from the AC power coming in, it's being converted to direct current like a battery DC. That's what the circuit sees. Whenever there's a audio transient, like feeding the loudspeaker, at any kind of modest to loud volume, big, peak swing, 10, 15 milliseconds or less, all of a sudden it's, big power supply inside that amplifier is, like a charge pump. It's just charging all these joules of energy right out to the loudspeaker, controlling the back EMF of that speaker and doing its job. Problem is that now a fraction of it, like ohms impedance of the power supply is now nearly zero. So to stabilize, it's trying to pull a bunch of current from your wall, as fast as it can and stabilize. Well, anything that you put in series before that power supply that raises impedance, be it a choke of an LCR filter, be it isolation transformers, be it a voltage regulator, which is a secondary AC amplifier, is going to raise impedance. When you do that, effectively you've got less than you would have gotten from your wall outlet, because your wall outlet's going back to the transformer to your building. Transformer to, that is probably anywhere from 100 to 400 amps capable, because we're not being limited by the circuit breaker, because those are slow acting. This is for a transient. This is 10, 15 milliseconds. Plus, the transformer is going back to, via very high voltage, the substation. So you've actually got a ton of headroom. And anything that you splice in series needs to, at the very least, not get in the way of that equation, and ideally would help it. In the case of the Niagaras, 3,000 up to the 7,000, we have a variation on power factor, except that it's for transients only. So we call it, transient power factor correction, or what do I call this? It's transient power correction, the TPC. But basically, all this is the means of lowering the transient impedance via AC, capacitance reservoir circuit. It's a circuit that damps it and works with it. It's a little bit more than just a part. But when you do this properly, you can have a reservoir for up to about 25 milliseconds or so. In the case of the 5,000 and 7,000, 90 amps peak. And what that does is it means that the very well designed power supply in said amplifier, that is fabulous at supplying DC power, but not really designed, to do everything that it could on the AC side of the equation. This is handling that. So all of a sudden you have a power supply that's closer to, 99 or 100% efficiency rather than waffling at 80, 85. It's just, allowing it in a transit to work well. If we all promise to listen to sine tones or pipe organ music, we don't need this.
Well, pipe organ. That's
what?
You were listening to pipe organ.
No.
Music. You don't?
No. No.
Garth, is there ever a situation where a 5,000 would be better than a 7,000 in a particular system?
Yeah. The thing about the limitation of the 7,000 was that when it was designed, I designed it for 2-channel audiophiles. So there was assumptions about what they would have. Both of those isolation transformers are limited for North America, for the North American version, to 5 amps apiece. You want a little headroom there, so let's say 4.5 amps. Well, if you're talking about any of the line level, preamplifiers, DACs, CD transports, streamers, that's not a problem whatsoever. They're going to be well under there. That's going to work out beautifully. Plus, you're going to have two levels of isolation, to where potentially Some of your digital stuff can be separated from some of your analog stuff. So even better still. Problem though, let's say we're also doing home theater, and perhaps we've got a projector, perhaps we've got a flat screen. Big flat screens can be right at the edge of that, that current limitation, and some of the projectors as well.
Mm.
Also, we have another issue, which is that if it's a large home theater that has different portions that are running throughout a household. I've also had some instances where people have used these in mastering suites and recording studios. That's rare, but like when it happens, one of the things that I did in the 7000, those isolation transformers are like balanced and ground floating.
Mm-hmm.
The high current outlets are earth ground. That's your return. Okay, in a 5000, the sources are still 20 amp capable. The entire piece is 20 amps RMS, but any one of them could handle 20 amps, and they're all referenced at earth ground.
Okay.
So basically, if it's something like a complex studio where I don't know what I'm going to interface with, and and grounding issues are going to be something I have to consider. And then if it's a home theater where I potentially have some very large flat screens or a projector, a 5000 is potentially a better pick. Also, combinations. Let's say, no, it's an audiophile system. I'm not going to plug in a projector or a flat screen to this, but I have all my sources on one wall, and then and then over on the far end, I've got two monoblocks, amplifiers, and my speakers. And I've got 20 amp dedicated outlets, ideally all on the same phase, all around the room. Okay, in a situation like that, what I would probably tend to do is a 7000 for the sources,
Mm-hmm.
and for the monoblocks, I could put those into a 5000. Now, if these are fire-breathing monoblocks, larger than a suitcase, and we really want to shoot the works, two 5000s.
Two 5000s, yeah. And what about tube equipment? If somebody had a full tube system, amps, preamps, everything, would you say a 7000 or a 5000? What have you found?
I have found that generally it doesn't matter if it's tubes, solid state. It doesn't matter if it's like digital or analog. Noise doesn't discriminate.
Okay.
Noise is a problem regardless. So we want to kind of like look at the same things. There was a period earlier when I was with Furman where I was, kind of like falling into the idea of like, well, different frequencies of interest, therefore I'll have like specialized filters for digital and specialized ones for analog. I don't believe that anymore. When I look at really what's going on, it's the same thing. Having some isolation between them, sure, but essentially it's the same 16 octaves of radio frequency induced noise that I've got to work with. And in terms of differential noise from appliances and radio, about 23 octaves. But, it's a situation where with vacuum tubes, there's a couple of situations I've run into with the 7000 where it's potentially possible to get those transformers to buzz a little bit.
Yeah, that's what we found.
Yeah,
we found
and
that.
the reason for that is that if you've got a regulation circuit in there, particularly that uses an output tube, sometimes what you can see on a scope, that's piggybacking the the feedback from the power cord to said tube preamplifier or something like that. It's like it's practically a little bit of a chopped waveform. It doesn't affect the preamplifier circuit itself. In fact, a lot of these circuits are world-class and sound fabulous. Unfortunately, it drives the isolation transformer into what's called magnetostriction, where the steel, tip core is imploding and exploding microscopically at 60 or 50 cycles per second, and about 5 or 6 octaves above that, and it's usually the 5th or 6th octave that you hear. And in a situation like that, the less current you put on the transformer, the better off it'll be. And on one that's really making it, go crazy, you use one of the high current outlets, on a 7,000, particularly bank 2, to get around that problem. But that's also a situation where a 5,000 with the best, associated power cords possible, in some ways, is the better choice.
Mhm.
It depends. It's not universally true, by the way, that if it's got a valve, don't use a 7,000 far
Yeah.
from it.
Mhm.
And I even have clients that because it depends also on how much harmonic noise is on their AC line coming in. I have clients and I have good friends. Actually, Joe Harley, who I talked about earlier,
Mhm.
he's got an audio research reference 3 and reference 6 SE,
Mhm.
in his system.
Mhm.
If you go up to the 7, he's got one 7,000 and a separate 7,000 for the amplifiers. And if you go, and you've got your, ear, within a foot of the place or something like that, you can hear it. But he just made sure to separate the two, into 2 different transformer banks from each other. And it's small enough in his room and from where he listens that he just never notices.
Cool.
Other people could have like a dead quiet room
Mhm.
and maybe a little bit more harmonic noise, or a different, valve product where it's more of an issue, and that's where a 7,000 makes more sense. It just depends. We also, occasionally even have problems with the transient power correction, but there's a switch on the back, and there's ways around that. There's workarounds for almost everything.
Speaking of line noise, is there any device that you could recommend that people could test their own line noise? For example, I know NTech makes a little portable device, and there's another company, I forget the name of it. We have both here in the store, and I like to tell the story. I went over to a local customer. His name is Jeff, and he was convinced, oh no, I have great power. You know, there's no way I would know if I don't have great power. You know, even on and on and on. Anyway, I said, let me just bring over a 7,000 and the line noise analyzer. So I went over there and I plugged it in, and it peaked the meter, and we could pick up radio stations on the thing. I mean, it was unbelievable the amount of line noise this guy was getting. I mean, literally it pegged the meter. So I took it out. He couldn't believe it. I plugged in the 7,000, plugged everything in, plugged in the NTech, and it was like 99% gone. He wouldn't let me take the 7,000 back to the store. He's like, you got to leave it. You can't take it. I've got to keep yeah, he was. I was like, I'll order you a new one. This is my. No. You can't leave with this without that. So he ended up keeping it, buying it, and he's been happy ever since. But that is the story. I think a lot of people are like, you don't really know. I mean, do I have line noise? Do I have these problems? But there are devices you can get out there, and some of them you can buy used on eBay for $50. You know, and they're little handheld devices.
Little
not
box.
only right.
Yeah.
Not only will you see the line noise, but you can hear the line noise.
There's a speaker in it.
Right,
Yeah.
there's a little speaker in it. So if you're sitting there going, oh, that's all snake oil, these guys do, you can do it yourself, measure it, and you can do before and after. So you can actually measure an outlet, get the line noise, plug it into the 7,000 or 5,000 or 3,000 or 1,200 even.
Any of them.
And see the percentage reduction of line noise. So it's something that's for the meter readers, they can prove them to themselves.
Yes,
This is really making a difference.
Good point.
Sure. Well, Fluke has had power analyzers for
That
serious power technicians, and the sort of thing that your local utility should have, like at least one of, and so forth. The thing about those is that they're $8,000 to $10,000, and there's a little bit of learning curve to be able to understand how to use it and what you're reading. So it's not really something that the public's going to embrace. Probably going back at least 20, if not 25 years, no, maybe even older than that, come to think of it. This company out of the Northwest, Seattle area, Audio Prism, came up with the first, consumer version of this. And it's a basic noise detector circuit. And then it took the, the incoming noise from the AC cord, just basically looking at differential. And it, basically took the, the noise signal, because that was mostly high frequency. It, created a little synthesis of the real noise that was there, limited in bandwidth. It's not
It's not the
detecting
full
all
spectrum.
noise.
Right.
Yeah,
Exactly.
it can't be. None of
No.
these ones are.
Right.
But it's only a fraction
Right.
actually.
Mm-hmm.
And then it just went into a little speaker and it had a volume knob. It was called the Audio Prism.
Mm-hmm.
The company still exists. They don't make them anymore. To this day, it's still one of my favorites.
Mm-hmm.
When I was at Furman, we licensed their technology, basically copied the circuit, but we added a sensitivity adjustability instead of volume. We just made it, like a little bit more useful for our purposes. I think Panamex, did a version of the NTech, which was, Monsters, name for the ones that they commissioned. Those were essentially a variation on that.
Mike, there was one that Vince at MSB recommended. We went out and bought it because he said it had
Alpha Labs.
Which one?
Alpha Labs.
That might have been it. It had a much bigger spectrum. Yeah. It had a bigger range, Let me see. That might be the one. That's it.
That's it.
That's it. That's the one.
Yeah.
Well, here's the thing about this. Like switching power supply, the cord, comes loose.
Right.
You can you can put an adapter on the end. You can bring it any place in the world because of the switching power supply. It'll still work.
Yeah.
It's really cool. You've got a number and you've got the speaker. So in terms of what you're doing of just getting this across to the client,
yes,
Virginia, there's noise on your AC line. You work beautifully. The fault to this is switching power. The original switchers, or not switchers, excuse me, the original AC, line noise analyzers were linear power supplies. This is a switcher. This means that its inexpensive power supply is creating almost as much noise as what it's detecting, number one. And number two, it actually has less range than a lot of the traditional ones did.
Okay.
So it's not 100% when it comes to seeing the difference between different products, manufacturer to manufacturer, or even within a manufacturer's line. It starts to get a little wonky, but it's honest. There's nothing dishonest about this thing.
Right.
And in terms of just what you did for the client, not a thing wrong with these, and very easy to use and very inexpensive.
Rick, I think we need an audio. I think we need an Audioquest version. The one that
that's a good suggestion.
Yeah, Garth, we'll keep you busy.
I would actually, at some point, if we have the budget and time, I want to rebuild the one that we did for Furman.
That would be great.
Yeah,
it's it won't be 1 1/4. It'll probably be closer to 6. But those were great.
But for dealers or for consumers out there that really want to know, it's great to have. It really does. It really is.
And the thing that I would bring up to people is a couple of things about this. Number one, the whole idea of like do I have induced RF in my system? Well, and then you get into the whole argument about we did things right with this new house or this McMansion or whatever else like that. Or you get the flip side of it. Oh, the power is terrible here because I've seen the lights dim, when we turn the vacuum cleaner on. Well, if you hit it on the quarter wave peak, that's hundreds of amps. So I'll bet the lights, dim, but they came right back most likely. People always think that bad power has to do with where your line voltage is sitting and so forth. And there's an aspect to that that's true, but no, that's not where some of the biggest problems for all of our components where noise is concerned has nothing to do with it. And further, it doesn't matter if you're in the hill or the valley, the gated community or the ghetto, your power is not good enough for the electronics you have for sale. It's not, it can't be. We lost that ability 30 years ago. Game over. Because as soon as we decided that we needed to have servers, on 24/7, in every office suite, in every school, every, home's got, multiple computers. As soon as we decided we needed Bluetooth, as soon as we decided we needed cellular towers, do you have cellular reception, in your sound room?
Yeah.
You got a problem.
Right.
Period.
Yeah.
It's that simple.
Yeah.
Unless there's no bars, congratulations. Otherwise, you got a problem because those sine tones, the sine waves are so ridiculously small. Yesterday's like a shielded cable, like yesterday's, oh, well, like my very sensitive circuit has got a beautiful, like a metal shroud, like a metal chassis that'll, like reflect away or absorb, like and drain away, all the induced, the radio frequency noise. That was true when I got started, mostly. Never totally, like 100, didn't get everything, but it got enough. You know, uh, think about the harmonic structure for like female vocal or piano or guitar or something like that. A key frequency like 3,000 hertz. When I was apprenticing at broadcast studios, and let's say it's like about 78, 1979, a broadcast facility would look at power then because they had to. You're looking at everything. Everything counts in that environment. Now, we'd get our current probes and everything like that. We'd measure the noise into a scope. At a frequency like 3,000 hertz, you wouldn't have seen a millivolt of noise at a frequency like that then. Up around, like the megahertz range, that would have been a different story. But, 10 megahertz, 1 megahertz or something like that, you could snub out, like most of those problems with parts that fit in the palm of your hand that cost the manufacturer like $3 or $4. If you wanted to do it, it wasn't that onerous a task. Today, if you're anywhere near a server room and you do the same test I did as a kid, it's not going to be a millivolt. It's going to be closer to 3 volts. 0 VU coming out of your preamplifier, for line level 0.775 volts. 3 volts, more than 3 times that.
Yeah.
The only reason we don't have, forget signal to noise ratio, the only reason we don't have a noise to signal ratio where it's almost all noise is because these electronics are actually made as well as they are. The problem is that it's a losing battle. You're always going to have a masking effect due to the incredible amount of low-level noise that's just permeating everywhere. It's in the cables, it's in the chassis, it's in the circuitry, and you got to have a way of dissipating as much of it as you can. And what you can't turn into loss or heat, you got to drain. And ideally, you could drain it back to earth. And that's essentially what I'm doing. It's making sure that a power amplifier's power supply can work properly. And ideally I can optimize it to a degree. And on the AC side, DC, that's up to them. And then it's making sure that all of that noise that's creating a masking effect and creating transient, like intermodulation distortion, I can lower. And then whatever I do along those lines, I do as consistently as possible. What an engineer would call linearly, but it's the same thing, or as linearly as possible, because nothing in electronics is ever perfect. But you want to do this because the other thing is, remember my original story about bringing that early balanced power conditioner, surge protector. It does everything, it's heavy and it's expensive, and the broadcasters love it, but I got such inconsistent results with my system. What was it doing wrong? Well, 2 things. It was adding impedance to the power amplifier, and for my source components, it was inconsistent in the noise it was reducing and then therefore trying to drain the rest of. At certain frequencies, it was down 40 decibels, and it went from this to this. And then in another, octave of the audio, range, the way it was, functioning with the circuitry, maybe it was only reducing like 5. And so it was kind of more like this. And then a quarter octave from there, it was 100 decibels down. But then an octave above that, it had a resonant peak, was adding 60 dB, and it was like this. And for 16 to 23 octaves, this to this to this to this to this to this. And also because this is all being affected by line impedance of your power, and because that's constantly modulating, because the amplifier is variable current, and because that's being affected by your music, you're this all over the place effect of unveiling the mask, low level information is constantly being modulated by, like in real time with your music. It's like taking a, like a 23 band graphic equalizer and, like asking your local neighborhood child to play with all the buttons while you're listening. It's only affecting your low level signal, not zero VU, but low level is where your harmonic series is. It's where the air around the instruments is. It's where all your reverb tails are. It's the size of the room. It's the imaging. The reason you can tell the difference between a Hamburg Steinway and a Kawai grand piano, the reason you can tell the difference between a Roth student violin and an Amati Landolfi or Guarneri, the reason I can tell as a drummer the difference between, one of my old Ks and, a B8 student level cymbal is, if you were to just look at compressed volume way up at the top range of plus 20 or 0V or something like that, instead of the incredible, engaging electronics you have at Suncoast, we could damn near do that with a boombox or a car stereo. That's child's play. Getting the low level signals, that's where the rubber meets the road. That's what matters, because that's where all the magic occurs. It's the stuff that's not at zero VU, but that's 40 decibels below, 60 decibels below, 80 decibels below, 100 decibels below. And the best electronics can do it. The best transducer can do it. The problem is that when the noise gets in, that's where
these things up. Yeah.
So everybody in the power game, or noise dissipation with cables and different accessories and things like that, and even acoustically. I think about some of the different companies like HRS. Everybody's trying to bring the noise floor down, and I applaud every one of them. They should, but whatever you do along those lines, unmasking things, you better be consistent about it, because if you don't try to linearize it, you are going to completely revoice your system, and in the most inconsistent way imaginable.
Garth, I know Rick has some questions for you.
Yeah, Garth, earlier you were talking about noise, to dissipate it or to drain it. I've heard some people online talking about supplementing their grounding system with more rods and in different locations, improving the resistivity of the ground path. How important is it to have a good earth ground?
Incredibly. Not everyone's going to have that opportunity. I'm a renter. I don't get to do it. But if you've got the ability to do it, by all means do so. Now, there's doing it right and doing it wrong. I will say that I'm a big bad believer in, if you have the ability to have a really well-made low impedance ground, like replacing the one that your dwelling or your home currently has, I'm very in favor of that. Having a second one put in just for my system, I'm completely not in favor of, because if you live in an area with lightning, you could get killed. You've got two different differentials now. That is a recipe for disaster. Never do that if you can help it.
I agree. Yeah, the main one by like where the meter comes in, that's where most of them are here in Florida. They ground up right below the meter. To improve that system, like put more rods further away and bond back to that same point.
So, exactly. No, that makes a big difference. And, because basically, like other than that, and, like the transformer from utility, making sure that that's in good shape and everything like that, it starts there. And then you go from there. Now, I've had some people that'll kind of say, well, I got my custom, like low impedance ground rod, we got a new, a transformer from utility, we've got, a custom wiring, a beautiful, a made perfect, breaker box and everything like that, beautiful bus bars and everything like that, great wiring, audiophile outlets in the walls. So I don't need what you do. I'm done. Well, tell that to 1 gigahertz. Because the problem is that when you got a sine wave where I can basically get 200 of them end to end and fit them on the edge of my Post-it note, sorry, the length of your power cords, might as well be a mile. you have to do everything that you can. But starting there with the way you're talking about puts you miles ahead. If you're lucky enough to be able to do it, by all means do.
Okay, great. Now, in the, we've got like an Audioquest Dragon cable here, power cord, and you can get it, from I think 1 meter, on up. Is there a certain length that you would recommend to get the most out of it? Like, does it have to be after a certain length? Or, I mean, I know you'd want this all the way back to the panel, but that's kind of impractical. But, is there a minimum length that gives you the most effect?
No. What we like to say at Audioquest is the best cable is no cable. But when we say that, we don't mean wireless. but we mean that anything that we create, falls short of perfection. And so basically, within ergonomic practicalities, the shorter the better. Other manufacturers will talk about an optimum length. Sometimes they have theories about, well, let's see, if we got a radio wave and I want to be a quarter wavelength of that and so forth, anything less than that is not going to be ideal. Nice theory. But usually what I find this has to do with is that if you have distortion, transient or modulation distortion typically, due to a resonant peak of, let's say, the dielectric to the the circuit that the cable represents, or the conductors and so forth. And when the basically when noise is modulating your 60 cycles, and that's coming in through the power supply, and that's eventually modulating your low level audio signal, and that's what your ear is keen to. When there's a resonant peak, you can end up with this problem that's really pronounced and ends up sounding very like transient or modulation tends to do, very, very harsh, wincing forward, maybe bright. And all of a sudden they notice, hey, I make this cable longer beyond a certain level, and the problem goes away. And from there, people start ascribing, well, quarter wavelength of a certain frequency. And basically what it really is you're taking a very sharp, what's called Q of a resonant path, and you're broadening the Q. You broaden the Q, you're coming closer to linearizing or damping your, about the resonant parts of your network, and you're getting a better, more consistent results. So with those designs, longer within a certain range, ideal range, and it'll vary from design, works better for that effect. I make sure that we don't have that effect anywhere in our cable.
Well, that's great. Now, one of the other cables we have is the Thunderbird, XLR. Did you have anything to do with the design of that?
Everything. They're mine.
Okay.
That's a dragon.
So, a dragon, I'm sorry. I thought it was a thunder. So we got a dragon power cord and a dragon interconnect. Can you tell us some of the design philosophies?
Well, I'm curious why it's braided.
Mike wants to know why you braided it.
A lot of people see that. And actually, the latest versions of those aren't even French braided anymore. There's a clip that allows them to go side to side the same way we were doing with the interconnects now. That just recently got done. But people for the longest time kind of like assumed, oh, well, the braid has to do with like twisted pair, and
it's like a noise canceling weave or something.
Nope.
Okay.
Purely ergonomic.
So just so it's more flexible, right?
Yes, that's why we did it. It was because if we hadn't done that, if we hadn't separated line, neutral, and ground on those power cords, we did an early version where everything was under one wrap. It's a spear. You can't bend the damn thing.
So Mike,
there's so much noise dissipation layers in those things. It was the only and really, really heavy individual conductors and everything like that. It was the only thing that we could do.
So Mike, these are the braided ones are no longer current. So we'll be having a sale on these demo cables after the show.
Call us after the show. We'll make you a heck of a deal.
I can assure you the performance is identical.
Now, Garth, I know the DBS pack was before your time, but maybe you can talk a little bit about it. It gets a lot of people
actually,
going.
The truth is that on everything that I do, I'm kind of like I'm standing on the shoulders of Bill Lowe, because he and the crew that he had assembled gave allowed me to work with a lot of good materials,
Uh-huh.
but I was allowed to take a clean piece of paper to everything.
Mm.
Anything that we'd done before that like it wouldn't work within my new designs or ideas, I could easily like cast off. As it turned out, I went back to certain fundamental things that they'd chosen because they'd chosen well. The conductor quality was superb.
Mm.
DBS was another thing that I kept, but the understanding of what it was and how it was being used got changed dramatically.
Mm.
Because, for example, in the old power chords, the idea of DBS, which is essentially just putting a dielectric bias. The dielectric is just the insulation material, usually between your high and low, like a conductor, or in this case, it might be between, like a blind and ground or neutral and ground.
Mm-hmm.
And in the old power chords, you would have a phantom conductor that went to the positive or the anode of the battery,
Mm-hmm.
72 volts. And, then you'd kind of come off of the shield, like a drain wire ground for the cathode or negative of your, of your DBS battery, like a power supply. And what that does is that creates a electrostatic field that linearizes and optimizes the electrostatic or dielectric at at upper tier radio frequencies. Lower frequencies really won't matter too terribly much at all, but this makes a difference because, again, we're trying to dissipate the noise and drain what we can't dissipate. So the more consistent, this masking effect, that you're dealing with is, the better off you're going to be. This is the whole advantage of DBS. Now, they had other theories about it when I got here. Because of my difference in background and everything like that, I was able to measure things, test things, listen to things, and kind of like start to understand. And then once we understood that, we were able to make some changes, one in implementation. For example, on a power cord, that DBS is actually, of the 3 different unique conductors, you have your neutral, you have an individual one for ground, and you have an individual one for line. It's only being used on line. And for this reason, because the difference between the line and the shield, which is where I want that optimum dielectric, that insulator is a shunt filter because line to ground is across the line.
Yes.
But if I'm dealing with neutral, the problem there is that is a low, and ground is ultimately going to the same place at the panel.
Yeah.
They're the same, like potential at high frequency.
Yes.
Which means that is actually not shunt capacitance, it's distributed capacitance. That's what I call the evil capacitance that I don't want. And I don't want it, basically optimize that. I actually, if anything, want that capacitance to be as low Q and lossy as possible. Ground, even more so. So you don't treat all 3 the same way, the way we would have done in the past, because their understanding was of such that if you learn something over here, well, we can optimize it over here. And barring no other evidence, that seems rational. But when you start understanding different parts of the circuit, it's better to target exactly what those parts need.
Yes.
So that's what we did there. Now, for example, and then another thing that was done was that everything that they'd ever tried DBS on, like whether it was a digital cable, an analog cable, an interconnect cable, speaker cable, power cable, it always made them better. So, and there were certain situations where even more voltage than 72 volts worked well. We had some customers that were, basically creating, series parallel connections and so forth with multiple packs and things like that. I think we had some people that were doing nearly 1,000 volts. We never do more than 72 volts because beyond that, you could hurt somebody.
You're killed by your battery pack.
Exactly. Well, you're not going to get killed, but you're going to know you're awake.
Yeah.
So
no, I mean, when it went up to 1,000 volts.
yeah. So there's that. So any rate, in working with all of that, I kind of realized, wait a minute, we've got this phantom wire that's only for the DBS. Then you've got your ground wire. You've got this outside power supply. You're putting this, we've got layers and layers of noise dissipation. And yet we've got this tail coming from the DBS that's an antenna that we're ejecting right back into this piece. Wait a minute. A, this tail should be coaxial. B, we need to filter this. So one of the proprietary filter capacitors that I developed for the 7000 is actually in every DBS module now. Has been for years.
Great.
Cool.
So that was, and whereas in the past, if you disconnected DBS from a cable because it takes so long for the electrostatic charge to fully develop and then slowly go away, if you unplug them, a naive reviewer would kind of say, it doesn't make any difference. Well, you have to wait a while. These days, because of the filter, you unplug that, you'll know in a second you did so.
Now here at Suncoast Audio, we sell cables that have stranded conductors and solid core conductors. Can you talk a little bit about why Audioquest chose the solid core and the sound our customers would experience with a solid core conductor?
So the problem is that, again, the best, cable is no cable. And all of these things are going to fall short. So the idea is that what's nice about stranded cable is it's very flexible. It's very easy to work with.
Yes.
The problem is that you're going to have interaction from one, wire, strand to the next strand, to the next strand, to the next strand. And there's a number of problems that go on. One is relative distance from one point to the next not being equal. If you do what's called a true concentric, number of strands and the way in which they're, they're laid out geometrically, you can mitigate that to a great degree. It's never perfect, but it's a lot closer to an ideal of one conductor or one strand.
And Audioquest does that in some of their lower priced power cords, right?
Yeah, we always try to get as close as we can to the ideal of one single conductor. And sometimes one single conductor just simply will not work. But when it can, particularly like in an audio interconnect, that's essentially what we're trying to do, because you're just going to have far less interaction and far less distortion where that's concerned. And then it's a question of what's the ideal conductor size for the bandwidth you're dealing with, what's going to deal with the primary signal the best, and also equally what's going to deal the most linearly with dissipating radio frequency induced noise. So you're looking at all of those things. And basically it's just a question of getting again, the distortion as low as we possibly can, particularly transient intermodulation distortion.
Okay, great.
What about capacitance? You and I have had this discussion many times.
I believe that, like in this Dragon interconnect, it's a low capacitance cable. It's not a high capacitance cable.
Yeah, it's definitely not. Compared to a few interconnects out there, it might be called medium, but even that's a little odd, because if you use a capacitance meter, and if your circuit is concerned about essentially seeing that number, I mean, there are some very, very low capacitance cables that'll be lower than it, but it's still relatively low. And then there are very, very high capacitance cables, because they have circuit blocks that add oftentimes it's a kind of like a variation on a Litz type configuration that's interwoven, where you've got your your highs and lows in very, very close proximity to each other with a very, very thin insulator. This drives your capacitance up much higher. Some circuits aren't terribly sensitive to it, others really despise it. It just depends. There's no hard and fast rule about that. And in the case of like an interconnect cable, if I'm honest about this, if you look at the if you're not dealing with like a passive preamplifier, if you're dealing with most of the circuits that are out there, they could probably handle the high capacitance about as well as low capacitance. There are some instances if we're dealing with very high impedance valve design or something like that, what's called Miller effect. You can start rolling off the top end if you've got too much capacitance on a long run, potentially there. But most modern designs and so forth, that's not going to be too much of an issue. The main thing that I'm concerned about is not the amount of capacitance, although I don't want it to be excessive, to be sure. The main thing that I want to look at is this. If we're looking at broadcast, like going back to the original days, might be 50 ohms, might be 600 ohms. For some radio things, it might be 75 ohms. But you had, essentially to make sure that wire runs or cable runs that were miles and miles and miles long had absolute minimum loss. You had matched impedance. Now, the circuits, it's almost impossible to do it this way. So you had isolation, you had basically output and input transformers that helped adjust the circuits so that your connecting cable would have, an impedance that matches what it's going to see from the source to the load where it's going to. And of course, a cable, unlike a electronic circuit, doesn't have its own intrinsic impedance. You take out an ohm meter or something like that, you're not going to see anything from high to low in terms of resistance. It's not there, but it's a characteristic impedance, which means that the cable was designed to specifically operate, correctly with the lowest loss if it sees a specific impedance at the source and the load. This is how everything in broadcast worked forever, and in a lot of things to this day. Our industry decided not to do this because we weren't going to use miles and miles of cable. We were going to use feet of cable or a few meters of cable at the most. And so it was excessive, and it was kind of like realized that not only are those transformers expensive, if they're good, but also they've got distortion and loss of their own. We didn't want that. So we, we hot rodded. We got rid of those things before I was born. I was born in 62. So, so none of our stuff, for the most part, there are exceptions, has anything like that. And that means that your source impedance, say from your DAC, your phono preamplifier, is a very different impedance than what it's going to go into the load impedance of your power amplifier or your, let's say, line level preamplifier.
Yeah, the source should be low and the device you're driving should be high.
You're a designer. You were back. You know this intrinsically, and that mismatched impedance is actually not a bad thing. It must be this way because if you try to, on the load end, get anywhere near the source impedance, what's going to happen? Your distortion's going to go up exponentially. Your highs are going to go away. It's going to be a mess. Most source circuits want to be very lightly loaded. So what's the problem with a cable? The problem with any cable in that scenario is that whether it's stated on the jacket or not, or on the literature, it's got a characteristic impedance. The designer might not even know what it is, but it's got one.
Now that brings up an interesting point. Audioquest, you designed this cable that I have here in my hand with 0 characteristic impedance. Can you talk about that?
That's exactly right, because you're ahead of me. Because the problem is that now I've got a source impedance that's one impedance, I've got a load impedance that's another one, and I got the characteristic impedance of a cable that's neither of those two. And further, at radio frequencies that's being induced, that's actually moving around with frequency. It's a mess. Remember the importance of linearization? That's the most nonlinear thing you could ever do.
Yes.
It's bad for signal transfer and it's bad for induced noise both. So how do you get around this problem? Well, I realized that a part of what gives you a characteristic impedance is the geometry between high and low conductor. I can't affect that. That's a given. I'm stuck with it. But it's also equally determined by what's called the dielectric constant of the insulator. Well, what if you were to just 100% shield your high from your low, terminate only on your load end? If you have no electrostatic field from high to low, you don't have a characteristic impedance anymore,
Hmm.
other than basically at the connectors.
Hmm.
It's gone over the vast majority of the length. And one of the biggest, like nonlinear problems and, causes of distortion in the cable, gone. That's I first started that with the power cables, then I brought it to the speaker cables, then I brought it to the interconnects. It's always implemented in a slightly different way because those three things are different, like currents, different loads, different
Yes.
priorities. But the idea is still sound because it's the same. Some of these problems are consistent throughout.
And by having this zero impedance, this helps Audioquest achieve the best possible sound in the transmission, whether it be a speaker cable, an interconnect, or even a power cord.
Yeah, because it gets closer to that ideal of no cable, of just the idea that the engineers have said for years, was just like, this is just wire. How can this make a difference? This is foolish. This is stupid. How can this make a difference? It's just a little bit of wire in between your circuitry. How can this matter? Well, the thing is that this is getting a cable a lot closer to that ideal where it starts to matter a whole lot less, and that's ultimately what we want. Get out of the way. Do no harm. But it's funny because for years and years and years, you kind of get the whole business of like oh, none of this can make of any difference. It's so foolish. I'll occasionally do seminars and everything like that, and I'll get reports later on where somebody's like, oh, what a bunch of snake oil. It's sort of like, come up and talk to me,
Right.
the people that always want to say this and so forth, because they're like the people I worked with early on when I was with Furman, the same people. And it's sort of like, I'm one of you. I'm a big believer in listening first, but I know how to run a bench. And not only that, but I'm a big believer in doing both. And the thing is that everything that we do, I can show you how to measure all of this.
Yeah. I think,
it's just that you're not going to measure it the way we did it in 1955. It's 2023. Do some work.
Yeah.
Now, one of the things that a lot of people would have a problem with in the engineering world, but I've heard the difference and I know it exists, is the direction of the wire. And I know that you have a second job where you have to listen to all these different rolls of wire to figure out the right orientation of them. So you're probably don't have a lot of spare time. You say, oh, I'm going in this weekend to listen to some wire.
Well, it depends on how busy we are. There were times during the pandemic where sales were booming, where I was getting a pile this high of wire samples, and it's like, that's a long day, God. And thing is that I could set up a test fixture to do this with a computer. The problem is that it would take hours per wire lead. I've set up a fixture where everything is repeatable, and I'm even down to where I stand. It's done with one speaker only, and I can do this in about 3 notes of the same recording I always use.
Wow.
It's seconds. It's just like everything else is training. I always like tell people that talk about golden ears and everything like that. Well, it all gets down to training and associating, like different things within a plane. Because if I go down to the local, like shopping mall or something like that, and I play a pop tune for 10 different people and say, can you tell me what key it's in? And can you transcribe it for me? In all likelihood, not one of them can. But that doesn't mean that's impossible or that effect doesn't exist. Because if I take the same test and I go to a music school and I ask a bunch of music school, graduate students, hey, here's this pop tune I just played you for the first time. What key is it in? 8 out of 10 will tell me, and at least 7 of them will be able to transcribe it really well.
Yeah,
it's just training.
That was a good point.
It's the same thing.
Yeah,
it's just like how, and I've done this, tens of thousands of times.
Check the direction of the wire.
Really, really, really quick at it. But basically, the whole way directionality works. When I first got here, they had all kinds of Bill had learned through experimentation with his crew that it mattered. And so they thought, well, if it's consistent, if we can hear it, even if we don't totally understand why, let's do it. That's part of the scientific process. Science oftentimes, it comes before the engineering, where they learn how to measure and the math behind it and so forth. I'm stubborn, and I come from the world of if I can hear it, I can measure it. So I wanted to know both. And also it's worth figuring it out, because if you can learn how to measure something, well, then maybe that'll lead to something else. So it's also good for the creative process and just further understanding. But basically, it's real simple. They had all kinds of ideas because different people, even John Curl at one time in a posting had kind of chimed in, well, it might be kind of like diode effect in a rectifier block. And I've kind of seen these RF effects before. And, there definitely seems to be a difference, but I'm not really quite sure why, and so forth, everything like that. And I literally saw things on the internet that were saying like, oh, yeah. Like a wire is a diode. No, it's not. No, it's a resistor. It's a series inductor. It is not a diode. It is not a Zener. It's not a rectifier. Where are they coming up with this from? And but it was just misapplication of some good information that was misunderstood. Okay. And people were coming up with all kinds of sophisticated ideas, and just ultimately, like so many other things in science, more times than not, the simple answer is the right one. It's resistance at high frequency. That's all directionality in a conductor is. Because when you're drawing a wire from a larger rod for whatever gauge you're going to need for stranded wire or for like solid conductor, it's always going to be drawn in a machine. And no matter how careful they are, how perfect the wire is, how many 0.99999s there are of the purity, the problem is, and even if you've polished the outside surface, that casting, which is kind of like sort of like granular, like and porous somewhat inside. If you look at it, chopped it and looked at it microscopically, you are creating almost like a chevron pattern, as you draw it. And it's very much akin to, you can see this, like with basic manufacturing of like human hair or like say horse hair, and in fact, if you think about the way a violin bow works or a bass or a cello bow works, it's rosin creating the friction on the string. But the reason the rosin stays in place so well, like through all of the heat and the action, is because of all those chevron, like patterns inside, like animal hair, including ours. Okay. Well, the thing about that is that's because, like as it works its way out of the follicle. Same thing with drawing the wire. So you're going to have these like chevron, like almost like steak knife like patterns right underneath the the outside surface. So why does that matter? Well, at low frequencies, it's irrelevant. But at high frequencies, it matters because of skin effect. High frequencies tend to run around the outside edge of conductive material, whether it's a chassis or whether it's a conductor. So the thing is that will still not make a difference at all, even if we're dealing with a digital signal or a radio signal. If you've got a cable that is, for example, basically single-ended, like positive, negative, below, it's always going to work the same way. Basically goes from source to load, down the positive, and returns down the low. So one of the things I was seeing that they were doing at Audioquest was that all this directional wire was all going in the same direction. It was like, well, that's not the way a circuit works. You understand the low is sometimes called a return. It's returning that way. Shouldn't half your conductors be going the other way? No, that doesn't sound good. That gives me a little bit of a clue. What I realized is that this has nothing to do with the circuit, because even with those imperfections in the wire, that's going to affect your transient modulation of noise affecting it. But your primary circuit, the current field is so strong, it's going to go up, it's going to go around those minor imperfections. It could care less. But what about a parasitic, signal, one that's independent of the primary signal? That's what's going on, because all conductive material is also an antenna. So you've got, you've got parasitic induced noise that's being picked up, and that's just looking for the path of least resistance, maybe ideally to go back to Earth or whatever, at least in the meantime, sees as the path of least resistance, just basic physics. Okay, so if you've got chevron patterns on just the inside of the outside edge, one direction is slightly lower resistance at radio frequencies than the other. And that's, so basically, if you oriented that towards the part of the circuit that's the higher gain, you're going to have less modulation of your low level signal. That's all we're doing. And originally they were only doing this with their primary conductors because they thought it had something to do with the signal. As soon as I realized what it really was, I said, like, no, every conductor. If you got a HDMI cable, if you got power supply wires, this needs to be directional. If you've got, like shield drain wires, directional. It's all the same thing. And I created like even more of a job for myself because now we're like basically testing 10 times what they originally did.
Wow. But making a great contribution to Audioquest.
We try. I mean, everybody works. And by the way, I do not work alone. I work with a team of really hardworking, talented people. I get to experiment and, like work with Bill and so forth. And like I said, I got a lot of, like really good work that was already done before I showed up. I didn't have to search the world over for, fabulous conductors.
Mm-hmm.
That work had already been done. It's not to say that in the future we won't come up with something even better, but that was already done. DBS, along with working with the patent shared with Richard Vanderstein, that had already been done. I just, basically refined it. There's certain things with noise dissipation that they'd already done a lot of work with. I just helped refine it and so forth, air tubes and so forth. So there was a lot of, good work that had already been done, but, we've just added a lot of things as we've gone. There's things that we do now with, optimized circuit, run-in that weren't done, before. For example, those interconnects, those Thunderbirds that you're holding,
Mm-hmm.
those go through a signal that is so much greater than those cables in normal use would ever see. It's so much voltage and so much current. Your mid-range driver would pop out of its socket, and the voice coil would go up in flames.
Mm.
And if it was capable of handling what we send the interconnect, you'd go deaf in a couple of seconds.
And is that to break it in, to condition it by doing that?
Yeah. Now, it's not full break-in because the thing, break-in is complex. DBS helps with that somewhat. Our, what we call, optimal molecular, permanent molecular optimization, is the name I think Bill gave it. But yeah, PMO. But it's a situation where it still will get better, I think, over the first, couple of weeks. But this mitigates a lot of it. And further, it does things to lower distortion that you could never do with 1,000 years on your system. Because your system would never put out this kind of voltage. And also, it's high frequency at AC, not DC. There are other companies that, kind of like DBS, that have made burn-in machines for years, and they make a difference. I've used them in the past myself, but to make them legal and to make sure that people don't get killed, they're direct current. Direct current's decent, but the problem there is that you can't be constantly pulsing with frequency. That's not how DC works. It's just straight line. The second thing is that there's no current, when you do it that way. So you're only putting so much dielectric stress on the insulating materials and on the connectors. In our particular case, we're putting a lot of optimal stress on them. And that's, and you figure out basically, as the military does with their, Jan spec mil spec capacitors, is where I, started doing this for the Niagara series with our film capacitors. It's a question of finding out what the maximum threshold is, back off just slightly. That's what you want to do for 24 to 48 hours.
Yeah, and you have big machines that you use for your capacitors for that. I mean, I've heard you talk about that you're burning in all these capacitors before they go into your power conditioning products.
Yep, and not my idea, by the way. I have to give credit where credit's due. NASA and Jet Propulsion's laboratories, like back from when I was a small child, Apollo mission.
Well,
It's
that's
still
great.
it's still a spec to these it's still a spec to these days. I don't, like when I was 17, I got to talk to one of the engineers that was in charge of the design for some of the film caps for those missions, and knew the specifics of not what the spec was or what the spec calls for, but the most important part, as I said much earlier in our talks, why.
Hmm.
Why is the key. And it had to do with, making these things far more linear, particularly at very high frequency, because in those days they were trying to build guidance systems and so forth with analog parts that these days are phones, would make child's play out of what they were building.
Hmm.
But but this is, you're going back more than, something like 50 years.
Hmm.
So those days it had to be done analog, and it was right at the edge of what everything could do.
Hmm.
And they discovered that they got more linearity at the highest frequencies out of a film capacitor that's not supposed to need any break-in time by putting it through this process.
That's interesting.
Yeah,
Yeah.
it
Huh.
is.
Huh. Rick, do you have any other questions? for Garth?
Last one would be looking forward with Audioquest. Is there anything that's not proprietary that you can tell us about that be coming up in a general kind of category, like in a cable or a power conditioner or something that gives our audience something to look forward to?
There's a number of things we're working on. There's a number of new, for our mythical creature series and dragon in particular. There's a number, digital cables that are still coming. There are tone arm and turntable cables that are coming.
Nice.
Mm-hmm.
There's all kinds of discussions about things we can do to help Ethernet.
Hmm.
It never really ends for us. There's always exploration. There might even be a dragon version of Niagara.
Oh, that'd be
Wow.
cool.
Yeah.
That's a
would
ways
be.
away.
Yeah.
That'd
But
be really cool.
but I in terms of being ready for the public, in terms of the R&D, it's already done.
Great.
I know Rick and I, one of the experiments we like to do, whenever we get a client that's a bit of a skeptic, and it's always around power cables for some
Yeah.
reason.
Yeah.
But anyway, one of the experiments we like to do, and I have to give Rick the credit for it, is we have an integrated with a DAC in it. And it's basically, a one box, right? And we'll bring people in and we'll plug in whatever power cord they want, usually the stock power cord. Let them listen. Then we'll shut it down, change just one power cord. That's all we do.
Just
it's
one.
the only thing we
Mhm.
change. Plug it back in. They can play their songs of choice. And every single time people are shocked. Oh, you must have done something else. You've changed something else. They don't believe it. And all we've done is change one power cord. And you hear more transparency, more resolution, more dimensionality. What do you say, Rick?
Yeah, it's like I like to say a veil has been lifted. You just get more of everything.
Yeah.
You get Garth's hand away from his mouth.
Exactly.
That kind of effect. Yeah.
Exactly.
Yeah.
And that's something people can do at home. I mean, if you're highly skeptical of, of cables, and there are people out there, and we have to qualify it by saying there are older systems I've seen that maybe not have the best setup, and the speakers are in a cabinet, and
It has to be a revealing system.
Yeah, and at that point, I'll be the first to say maybe cables don't matter. With your Kenwood receiver from 1970 and your Bozak shoved in a box and
pointing the wrong way
in your 1974 wood wall unit. Yeah, they may not matter. But if you do have a high resolution system, if you've got a resolving system, then you can certainly hear differences with cables for sure across the entire spectrum.
And I'm gonna say something else too, along these lines, particularly where power is concerned. I think for audio and digital cables, sometimes just the fact that the some of the various types of distortions, and particularly again in transceiver modulation, is going to lower. Um, you're going to hear that with almost anything that you use for your source material, but for power, because so much of this is unveiling low-level information. If you were to, it's not that you wouldn't hear a difference in that power chord playing something that's been slam limited with, like for Bluetooth in ears, like
Compressed.
like
Yeah.
that with 3 dB of dynamic range. Literally, it's not that you wouldn't hear a difference, but the difference will be really minimal. But on the other hand, if you've got something that's wide open with 60, 80, 100 dB of dynamic range, now you're talking.
Yeah, exactly.
Yes, exactly.
That's what we found too.
Yeah.
Yeah, because that's where the corruption's going to go. And by the way, for the, and again, I think we talked about this earlier, but for the naysayer engineer that's like, I know better, I'm going to save you from yourself. The thing is, I can show, just talk to me. I can show them how to measure this. Like on our website, Power Demystified, first 2 or 3 pages, of that thing. I mean, it's not going to be for everybody. Granted, it's technical. It's not a lot of scary math or anything like that. But for most people, if you got insomnia, read up. But the thing is that the first couple of pages are about the digital difference file tests that I've been doing since my Furman years. And we went to Bernie Grunman Mastering to have this done. And not that I couldn't do it here, but I wanted to follow the whole, guidance of independent lab, independent engineer, verifiable, repeatable, peer-reviewed. All the things that people want to bring up about how you're pulling something, I know better. No, you can absolutely get the same results as me. And all we did on these tests is change one variable at a time. And it absolutely conclusively proves, want to see a third of your low-level signal go away? Plug everything into a cheap strip.
Yeah,
absolutely. Mike, do you have any questions for Garth?
My question is, okay, you have the 3,000, 5,000, 7,000. What about the 1,200? What's the difference between
the 1,200 and
just
5,000?
Okay. Yeah.
Well, a 1,200 was meant for smaller audiophile based systems. We no longer make them. There a lot of dealers still have a certain number
got it. Okay.
in stock. The 1,200 doesn't have the transient power correction for power amplifiers. We couldn't afford, or nor do we have room to put that circuit in to those particular units. But that 1,200 is a peach.
It is.
It has all the other things that make a 3,000, 5,000, 7,000 special. The burned-in caps, the custom-made, PC boards, all solid conductor wiring, everything directional, just on and on and on and on and on. It's a really, truly great unit. The reason it's gone, by the way, is twofold. One, we've got a new medium-priced, power, line that's just now being released over the next several weeks.
I was going to ask.
The 330, the
505, and 707.
Yeah.
707 is in the price range that the 1,200 basically ended at, around, 13 to 1,400. I'm an engineer, never trust me for prices. I'm always wrong. But I just build them. But anyhow, the thing about a 1,200, one of the reasons, two reasons it had to go away is that a good deal in North America of our market is not just audiophiles, but custom install. The 1,200 was never meant to be in a rack. It was meant, to be behind an audiophile equipment cabinet or on one of the shelves. Works perfectly for that. But, but really, custom install, they want nothing to do with it. So that was ergonomically, strike one. Strike two was the Niagara line, because just so much is done by hand and so much is custom parts that we have to ship overseas and then they have to ship back. And it was going to, if we kept making them, it was going to be $2,000. And for that form factor, it was like, no, let's just, like you jump up to the 3,000. In another 2 years, we'll have a slightly less expensive cousin of that or something like that, and that's how we'll deal with that.
Mhm.
Do we have any 1200s left, Mike? We may.
We might. I'm not sure about
Yeah.
that. We'd have to check, but
Yeah.
yeah.
Well, the new one, you're right.
I'll
is-
tell you what, though,
Mhm.
that 1,200
It's
I've compared
it's
to
awesome. Yeah.
what I was able, the best I knew how to build when I was at Furman at $4,000, and it just with an Energy Z3,
Mhm.
it stomps all over
Mm.
it.
Yeah. It's very, very good.
Mhm.
Rick, any other questions? for
No,
us?
we've covered a lot today. So,
Yeah.
no,
Garth?
I think that's it. I mean, Garth spoke very eloquently
Yeah.
about a lot of subjects and
Yeah.
gave us some great information.
Very, very good. Garth, we
Yeah.
know how busy you are, and we appreciate all the time that you've spent with
Anytime.
us today.
Yeah.
And I will look forward to seeing you probably at the next show. I don't know. Where are you going to be next? Do you know?
Let's see. I'm not at Cedia this year.
You're going to You're not
so-
going to Capitol, right? I doubt you go to
I'm
Capitol.
not going to Capital. No, I think it's going to be
Yeah. Munich,
I think it's going to be a
Exponent.
little while. I think I think they're going to, like ship me around to a couple of different dealers for
Uh-huh.
some, for some like just like local dealer shows and so
Huh.
forth. But I think to the end of the year, that's mostly what's going on.
Okay.
And then after the first of the year, I would recommend the Florida Audio
Florida
Expo,
Audio
the
Expo.
International Florida Audio International Expo.
the International
You should come
Florida
to that.
International Audio
Yes.
International
Yeah.
Expo.
We'll be
Yeah.
there.
Yeah, we'll be
There
there.
we go. Yeah, there's a certain, there's a certain RSM you might know that probably needs to really pitch, mightily for that.
Yes,
Mhm.
yes, absolutely. Well, thank you again, Garth. Greatly
Yep.
appreciate your time today. We know
Thank
how
you.
busy you are, and we really appreciate all
Yeah.
the time you
Thank
spent
you very
with us.
much, Garth.
Thank you so
Mike,
much.
Mike and Rick, thank you so very, very much.
You're
It's
very
my
welcome.
pleasure. Anytime.
Thank you
Okay,
so much.
great.
Thanks.
Mm.
Bye, everyone.
Bye-bye.